Good morning, everybody. Welcome back to lecture number 21. Today we will continue based on lecture 20.5, where we talked about the power concepts. Okay? No, I don't want this. Again, all of you, bring your calculators. You have to do power calculations. So last time, we talked about the concept of if you have a resistive load, you will have only real power that is going to be in phase with the V and an I, but half or twice of the frequency. And its positive average value is positive, which is Vm Im over 2, and it's in a form of dissipating heat. For inductive loads, if you just have only inductor, like that circuit, always look at the circuit, you will have an average power of 0, and you will have a reactive power that has a formula Vm Im over 2. This over 2 comes from square root of 2 for Vm times square root of 2 of Im. Get it? Then if we have a capacitive load, we will have the same reactive power, but it's negative. Now these three slides are not really important because you always have a mix and match of R and L and C circuits. Get it? This is only if you have that circuit, which is red. We talked about these generic formulas, and we talked about the angle where delta sub V minus delta sub I is 90 for that only inductors load, and minus 90, which is only for only capacitive loads. Then we said, what if we have a general load? We'll have R plus Jx, where x can be either omega L or minus 1 over omega C. If it's minus 1 over omega C times J, or 1 over J times omega C, that's going to be a capacitor. The generic formula, after we did the derivation, comes into three different terms. The first term is Vm Im over 2 cosine theta times 1. This has an average value of Vrms Irms, which is Vm Im over 2. It's the same, cosine theta. Then another term, the same thing, you multiply by cosine 2 omega t. This has an average value of 0. The third term is Vm Im over 2 sine theta sine 2 omega t, which also has an average value of 0. What does that mean? That means the average power is only that term. The other two terms have 0 average. Then we define the power factor, which is cosine theta. Then we said define a quantity called reactive power, and we just took that expression, Vm Im over 2 sine theta, without the 2 omega t, just this term. So this term, the only difference between this term and the p, cosine, it becomes what? Sine. It's still in the same big equation. This is big equation. We call the reactive power has a unit of volts times amp, reactive, just the word reactive. Then we define the apparent power. The apparent power has this symbol, absolute value of S. هي الطاقة الظاهرية, which is P squared plus Q squared. If you do cosine squared plus sine squared, that's 1. You will have that term, which is nothing but you take Vrms, Irms, or you take V peak over 2 times square root of 2 times I peak over square root of 2. You square everything. This is the apparent power, which has the unit of voltage times amp. There is no word reactive. Then we talked about the power triangle, and we said the power triangle can give you P and Q and absolute value of S. This is the absolute value of S, okay? Then we ended with this slide. We'll talk about additional power relationships. We said, okay, the average power is Vm Im over 2 cosine theta. What if I replace cosine theta with R over Z from the triangle? Okay? From the triangle, R over Z is cosine of theta. And what if I replace Im with Vm over Z? I will get Im squared over 2R. Very similar expression to the power in chapter 2, which is P equal I squared RMS or V squared RMS over 2. Over R. The key here is you're not putting the peak values, you're putting what? The RMS value. So memorize the blue formulas. For reactive power, you replace R with what? Just X, without the J. We do not put the J in the Q formulas. For inductive load, X is positive, plus omega L. For a capacitive load, Brahim, X is what? Negative, which is minus 1 over omega C. Today we will introduce a new quantity, which is what if I pull that complex number, which is called S, which has a value of half V times I conjugate. What does this star represent? This star represents the word conjugate, اللي هو المرافق. Do you remember in math 001, if I tell you 1 plus 2I, what's the conjugate?
Minus 2.
It's 1 minus 2I. So the same concept is applied here. What if I have divide by 1 minus 2I? What's the conjugate? You take the conjugate of the numerator and then the conjugate of the denominator. So what's the trick? The trick, whenever you see an I, you replace it with, change its sign. You change the sign of every I and J. So that's the only thing, is you change the angle. And we can see it here, half Vm theta V, we keep the angle, but with the I, we change the current, the angle of the current. So that's how the conjugate is applied. Another way, if you have one angle 90, which is J, what's the conjugate? It's one angle minus 90, which is minus. Get it? Math 001, Shargawa. Abu Nassar, get it? What's the conjugate of one angle 90? Which is minus J. So you just change the sign of the J. I call this formula the fundamental theorem of power systems. This formula can help you analyze every transmission line in the grid. So this formula, I am going to put a big heart on it, okay? I love this formula. I have been using this formula all over the years, so please memorize this formula, because this formula can help you derive the average power, Vm Im over 2 cosine theta, and the other one, the reactive power. So we can say it's equal to P plus J times Q, where P is this expression, Q is that expression. So the first term is the average power delivered to the circuit, which is usually the resistive stuff. The second term is the reactive power, which is either delivered or absorbed, which is either the capacitive or the inductive load. Now let me ask a question, why half? Because we have 1 over square root of 2 for the voltage and 1 over square root of 2 for the current, because half is what? Is 1 over square root of 2 times 1 over square root of 2 V I conjugate. Keep in mind this V and this I are the peak values. They're not the RMS.
Doctor?
Yes.
كيف نمثل conjugate في phasors?
Well, you just flip it 180 degrees. So if you have, for example, I here, I conjugate is this one. Get it? Keep in mind the apparent power absolute value of S, which is here, the previous slide, is nothing but VRMS times RMS, or V over square root of 2 times I over square root of 2. Let me ask you a question. Ibrahim, is VM peak or RMS? What is sub M here? Max. So that's the peak. Get it? Get it? Hatem. Why again we have the half here? Because 1 over square root of 2 for the RMS value of the voltage, 1 over square root of 2 for the RMS value of the current. Okay? So the average power is the real part, the reactive power is the imaginary part. There is a command in Python or MATLAB for real and imaginary. So in summary, those are the formulas. Okay? Average power is what? VRMS times IRMS cosine theta, or half VMIM max, okay? The reactive power is VRMS IRMS sine, or half Vmax Imax sine theta. Apparent power is VRMS times IRMS, or half Vmax times Imax. Remember, if you have a sinusoid, this is Vm, the constant value is VRMS, and Vm equals square root of 2 VRMS, or 1.4. Get it? Very important. Yes, very important. Then we talked about the complex power, which is this, which has this formula. Again, this Vs and I conjugate are the max. They're not the IRMS. Okay? Or VRMS. S is what? Source. The units are watt, var, VA, VA. The power factor has no unit, which is cosine of theta V minus theta I, and that is the power triangle. Example. Let's do this example. Compute the power and reactive power taken from the source for the circuit in example 5.6. So again, we are so professionals. I am not going to solve it completely due to the, we really don't have time, but I will explain to you how to do it. I'm not gonna write it in board, but I'll explain to you how we got the numbers to really save time. Okay? So first of all, Vs is 10 angle minus 90. This is J100. We did it in the previous example in the help session. And those who attended the help session, they got quiz 410. Those who did not attend, you have to do a very hard quiz 4. I'm sorry to tell you. We had, I think, only 5 students attended. I said, okay, I'm going to give them 10 points. Those who did not attend, either because of a midterm, next week you have a quiz. Okay? All chapter 5. Again, I prefer this formula. The question, always read the question. Compute the power and reactive power. When we say the word power alone, it means what? Real power, Abu Nassar. When we say the word power, if you don't want to attend the class, feel free to leave. Okay? When we say the power is what? It's the real power. لما نقول طاقة ونسكت, it is the real power, P. Or and the reactive power delivered to each element. 1, 2, 3 elements. Okay? He already gave you all the currents, calculated all of them for you. So we use the fundamental theorem of complex power, which is V equal half. S equal half Vs Is conjugate. Again, is this a max or RMS? Is the 10 here max or RMS? Max, it's Vm. So it is half times, what's Vs? 10 angle minus 90 times I conjugate. What is the current? 0.1414 angle minus 35. The conjugate, you just change the angle from minus 35 to plus 35. Nothing, don't say one, say plus, okay? 1414 angle plus 135 degree. So what's the answer? The answer is already written here. It's 0.5 plus J 0.5. So the real power is 0.5 watts. The imaginary power is 0.5 VAR. What's the unit here? VA. Okay? So, yes. No, it's the same. If you add plus 80, it's like subtracting minus 80. So just change the sign. That's the best way. If it's 60 degrees, it will be minus 60. No, it's not 180. You just change the sign. No, I gave you an example. Well, forget about the phasor example. I think that was wrong. No, that was wrong. You just change the symbol. The calculator has a complex. For example, if you have the 5 angle 30, you hit shift 2 and then conjugate 2. Which is 5 angle minus 30. What did we put before? 5 angle 30. This conjugate is. So you can calculate the conjugate by calculator. Shift 2, option 2. Okay? Now, another method is you take the formula half V max I max cosine theta or VRMS. So you can take the formula here where we did, for example, the for the reactive power delivered to the inductors, you can use the formula directly, which is I squared times X. X is 100. So the current here is 0.14. This is 0.1 is actually 0.14 divided by square root of 2. Square, that you get 1 var here. For the capacitor is 0.1, that current, 0.1 divided by square root of 2. I think it's 0.144 divided by square root of 2, just to make it better. Okay? And then for the capacitor, it was minus 0.5. 1 minus 0.5 gives you the total from the source, which is 0.5. So the 0.5 became 1 var here minus half a var here. It means what? It means the capacitor supplied the inductor with a half, and the source supplied it with a half var. And it was all stored in the inductor. Get it? Now, we can verify that the reactive power delivered by the source is equal to the sum of the reactive powers absorbed by the inductance and the capacitance. So the capacitor absorbed minus half, which means it supplied plus half. The source supplied 0.5. It was all went to the inductor. Basically, the summation of all the powers should be equal. Whatever supplied by the source equals to whatever absorbed by the loads. Now, I personally prefer this formula, okay? That's why I put a heart on it. I didn't put a heart in these formulas, but they can be useful, okay? Because I know already, I can always find the complex power here, find the complex power there, and I'll get the same numbers here. Okay? Should we try the resistor? S sub resistor equal half V R conjugate? No. I conjugate. So what's the voltage drop across the resistor? Voltage drop is not given. Forget about it. It's going to take time. But I can use this formula. So because I don't want to do circuit analysis, I calculated using the formula for the resistor, which is IR, which is 0.1 over square root of 2 squared times R. 0.1 over square root of 2 squared times R. Basically, we applied the formulas in blue. Okay? Note that the real power for the capacitor and the inductor are 0. Okay?
Should I memorize all those formulas or some of them will be new?
I don't know yet. I have to talk to the coordinator. I'll push for giving it to you, but we'll try to do it. Again, if you write this fundamental big formula here, if you memorize this formula, you can know the reactive power, the real power, and then you can derive it. Maybe we'll give you a formula sheet. I don't know yet. Any question about this example? It's a very important example. Yeah.
Doctor, in the solution, go up. The power here is RE of S. Is there a function? I saw that there is a
No,
function.
RE is real. Basically, you take the real part, which is 0.5. IM is imaginary. You take whatever multiplied by the J, which is 0.5. And this has a unit of var. Now here, because I don't know the voltages across each element, I had to use the formulas. So Q sub L is I RMS square times X of L. I RMS square is 0.14 divided by square root of 2, which is 0.1 square. That's 1 var. For capacitor, the same, it's minus 1 var. For resistor, it's I square R, which is 0.1 square times 100 over square root of 2. Remember, in the powers, we always calculate the RMS values. Okay? The other problem is, consider the circuit shown in figure 5.29. A voltage source delivers power to two loads connected in parallel. So we have load A, load B. Now, from the wording, this is a leading, power factor leading. We know, because the power factor is leading, the word lead means this is a capacitor. B, the power factor is lagging, so this implies that this load is inductor. Now, by the units given in the figure, we see that load A has what? 10 kVA. What is this 10 kVA? 10 kVA is the absolute value, is the apparent power is 10 kVA. So what is power factor? 0.5 leading. So that's for A. For B is what we have. We have kilowatt. What is kilowatt? Is it real power, reactive power, complex power? Real power. So P sub B is 5 kilowatts and the power factor is 0.7 lagging. So from this information, I know that 0.5 leading means the current leads the voltage. It's another way saying load A is capacitive and lagging is what? Inductive. Because A has loading that's capacitive, power factor, we can calculate now the power factor. So we can calculate the formula for, so I already know S, so now it's time to calculate P sub B. The P sub B is what? 1 over, or V RMS, times I RMS, times cosine of theta, right? The real power, or we can say half Vm Im cosine of theta. But I don't know the voltages, but I know this quantity, which is what? This is absolute value of S, the apparent power, times cosine of theta. This one is the power factor. So I can multiply 10 kilo times 0.5. And this is what? This is 5 kilo var. Watts. So now I know the real power of element A. To calculate the reactive power from the power triangle for a leading one, so I know this is S, this is P, this is Q, so Q is what? Square root of S minus P. مثلث قانون فيثاغورس سكوير. الوتر تربيع ناقص المجاور عشان تحسب هذا. So Q, so I'm sorry, that's sub A, not B. Q sub A is what? Square root of 2 of 10 kilo square minus 5 kilo square. If you do the math, you will get, we put a minus 8.66. We put a minus why? Because the angle here is negative for leading power factor. Go back to triangle. So theta is negative. The angle is negative, so Q is to the bottom. Okay? The other triangle for, so now we're done with the first triangle. We know Q, we know S, we know A. You do the same calculation for the inductive power load or the lagging. You already know the real power, but you don't know S and you don't know Q. So the first step is you have to calculate what? You know power factor is what? 0.7 lagging. So the angle theta is arc cosine of 0.7, and you put a positive. The angle is positive. So what is that number? It's 45 degrees. 45.6 degrees plus. Now, in that triangle, I know the P. The P is what? 5,000 watts. I know the angle is 45 degrees, 45.6 degrees. So what is the absolute value of S? From the triangle, or I can calculate the Q. What's the Q? Q is what? Q sub B equal P sub B tan of theta. Because tan of theta is Q المقابل على مجاور tan theta. So that's equal to 5,000 times tan of 45.6. So 5,000 times tan 45.6. That will give you the quantity 5.101 kilowatt. Then I can know S easily by, there is a J here. No, the question asks find the real power, the reactive power, and the power factor for the source. So remember, we wanna know this. Yes.
Victor, in the S equation, do we have to use the maximum voltage or the average?
Which equation?
The first one.
No, this one is max, which is equal to V RMS I RMS conjugate.
هذه من الصف.
Yeah, S sub source. You can add an S before. Now, I know QB, PB, PA, QA. So I sum PAs and PBs, which is 5 plus 5, which is 10 kilowatts. And this is for the source. The source is delivering 10 kilowatts. And it's delivering the Q, which is minus 8.66 for the A, plus 5.101 for the B, which is minus 3.559 kilovars by the source. Now, always remember, the question did not ask you to calculate S for the B. He didn't ask you. He only asks you to calculate the real P, the reactive P, and the power factor. So, what is P sub S? P sub S is what? 10, right? P sub S is P sub A P plus P sub B, which is 5 kilo plus 5 kilo. Q sub source is Q sub A plus Q sub B. Q sub A, I calculated it here, minus 8.6 kilo, plus Q sub B is 5.101 kilo bar. This would be minus 3.559 kilo VAR. So this implies S, the complex power for the source, is PS plus J times QS, which is 10 kilo, minus J times 3.559. The unit is, well, we can put the kilo here, kilo voltage amp. From that, I can calculate the angle of the source, which is theta, which is arc tan of minus 3.559 over 10. If you do this by the calculator, you'll get minus 19.59. Keep in mind that because Q is negative, we will have a triangle like that. This is minus 3.6. This is P equal 10. So this is power triangle for source. So theta is what? Tan inverse of minus 3.6 over 10, which is minus 19.59 degrees. So what's the power factor? The power factor O is PF is cosine of the angle minus 19.59, which is 0.9421. It's positive or negative. The angle is negative, so it is minus, so it is leading. Remember, cosine of an angle always going to be positive. Okay? No, not cosine. Cosine of a positive angle and a negative angle will be the same number. هي دالة زوجية. Cosine of x equal cosine of minus x. There is no negative here. The leading because there is a negative sign here. Okay? This example, the power triangle is not my favorite, but you see how to solve it, 5.10. Again, the complex power delivered by the source is 10 minus J, which is this angle, or it's equal to this quantity. Finally, I can calculate the current using the hard formula. And how to calculate it is very simple. So S conjugate is 2 times S divided by Vs, which is 2 times. What is S? 10.6 angle minus 19. This is kilo. Divided by the voltage level. What's the voltage level? 1414. Angle 30. Remember, this is I conjugate. So what's the answer? Two times 10.61 kilo angle minus 19 point, I forgot what's the angle. 59 divided by 1414 times angle 30. So that is 15 angle minus 49.59. This is I conjugate. So I of S is what? 15 angle positive 49.59. The unit is what? Amps. Let me repeat that example. I don't care. We're late in the تقريم في المنهج, but I don't care. This example again has a voltage source and box A and box B. Box A has a real power of P and it's leading. So this tells me it's a triangle with heads up or head down. It's heads down, negative angle. 0.7 lagging, it's heads up, so the angle is positive. Here I have P, here I have absolute value of S. From geometry, I can calculate P sub A, which is VAIA RMS, which is 10K, which is 10 to the power 4, times cosine theta, which is 0.5. So now I know P. Q is calculated by نظرية Pythagoras, which is the square root of 2 of the apparent power minus the real power, which is going to be a negative number. Then I calculated theta, which is r cosine of 0.7, which is 45 degrees for the second triangle, and it's heads up, so it's a positive angle. Then I calculated its Q. Then I combined the P of A and B plus Q, A and B. And now I got the total complex power, which is 10 minus J times 3.559. Not only that, I also need to calculate the angle of this number, which is minus 19.59. We take basically Q over P. So we got the number minus 20 degrees. Then I use that formula, S equal half VSI conjugate, to calculate I. So it's 2S over V, that's I conjugate. And I get it with a minus 49. So I is what you replace minus 49 with plus 49. That's how to convert from conjugate to regular without conjugate. That is this example in a nutshell. And again, the current leads the voltage because we have a negative angle, or the power factor is 0.9421. Try to solve this example at home, okay? We solved 2 examples so far. Okay, now, we have 8 minutes, we'll try to talk about. Enough about power. If you're struggling with power, come to my office and watch lecture 20.5 and today's lecture, then you will get it, okay? Thévenin and Norton equivalent circuit. Do you remember Thévenin and Norton? So we can replace a resistor with a box called impedance Z and Norton with impedance Z. What is the equivalent impedance? It's what? 100 parallel with minus 300, because we kill the current source, we short circuit the voltage source. So what is 100 parallel with minus 300? Do it with the calculator. It's what? 100 inverse plus. It's 50 minus 50J, right? So Z Thévenin is 50 minus J50, right? What's the unit? Ohm. Here we did calculate Norton equivalent, not Thévenin. So to calculate Norton, we calculate I short circuit. If I make an I short circuit here, that's 100 angle 0. Is 100 max or RMS?
Max.
Max. 100. And then I short circuit. And then I have a current source. Is the current source 1 angle 90 max? Is 1 max or RMS?
Max.
Max. Then I put a short circuit. If I put a short circuit, what will happen? It's like eliminating. We're short-circuiting the capacitor. So I remove it. Do you remember that example from chapter 2? So what do we have now? We have IR. And then I have I short circuit here. Remember the current source and IS. So IR equals I short circuit plus 1 angle 90. This current equals this current plus this current. If you short circuit the current source, that's okay. So, what do I want? I want to calculate I short circuit is IR minus 1 angle 90. What is IR? IR is 100 angle 0 divided by 100 ohm. What is the voltage here? What is the voltage here? I'm short circuiting. What's the voltage here?
To be the same.
It is same, 0. Hatem, what's the voltage here?
0.
Can I do it this way? So the current IR is V minus 0 over R. Which is what? 1 amp, right?
Yes.
1 angle 0. So 1 angle 0 minus 1 angle 90. What's the phasor?
Minus.
1.414 angle minus 45, right? Correct?
Yes.
So that's the I Norton. So I can write the equivalent Norton model to be R Thévenin. Okay. So I put a current source here. What's the value of that current source? 1.414 angle minus 45. What's R Thévenin? 50 minus J50. Can I find V Thévenin? Put R Thévenin the same. And what's V Thévenin? It is source transformation. 1.414 angle minus 45 times 50 minus J50. So V Thévenin for this problem is 100 angle minus 90 volts, here amps. So now I found V Thévenin and I Thévenin for this problem. The only difference is you replace R with Z's and you move. It's the same thing, okay? Okay. Any question about this example 5.12? Okay, do you remember what is the maximum resistance that gives you the maximum current? It's R Thévenin. Here it's not Z Thévenin, it is Z Thévenin conjugate, which is R Thévenin minus JX Thévenin. So, what is the maximum R for this example that gives you the maximum power? 50 plus J50 plus, we take the Thévenin big star, big star, big star, okay? Don't forget about it. That's what the slide tells you. We need to find the load for the maximum power, given it has an internal impedance of Z load is Z Thévenin conjugate. Okay? Keep in mind the absolute value of it is the same. Now, also, if I'm allowed only to connect resistors to the system, why we say that? For example, if I'm only allowed to connect heaters, then there is another formula which is, instead of connecting 50 plus J50, I connect what? 50 square plus 50 square. And that's what? Square root of? Whatever. 2 times 50 square. So if I connect 50 square plus 50 square, which is R square plus X square, if I want to have only resistive value. So there are two options for maximum power. Either I connect Z Thévenin, I can bring a combination between resistor, capacitor. If I'm only allowed to extract the maximum power for a lamp or a heater, I can cheat by getting the magnitude of that maximum power transfer and get it as a form of resistor. So here that box can be only R or R plus either capacitor or inductor depending on Z Thévenin. Hatten, if I bring the question in the test, can you calculate Z Thévenin? Can you calculate the maximum power? Z Thévenin what? Conjugate. What's the trick with the conjugate? You replace the minus J with plus J. If this was plus, this will be minus J. Get it? Okay, you can leave. You have any questions? The quiz Thursday. Next Thursday. All chapter 5. Who attended the session? None of you. None of you. YouTube. It's in YouTube. I put it yesterday. Did you see it in YouTube?
Wow.
That's why you didn't understand today's lecture.
Because I had to.
I don't care. Not my problem.